Hi, I'm Sheree Morgan, the INL Radiological Control Director. The INL Radiological Control Organization is continually working to improve the Radiological Protection Program. It was identified through radiological control, self-assessments, third-party reports, and observations that there were issues with the radiological work permit and ALAR review writing processes. For example, some of the findings stated the RWP did not clearly define the radiological hazards or work scope. The RWP was too lengthy, and the RWP contained too much specific information and instruction. As part of the radiological work improvement effort, we have created a leaner RWP process. A team of stakeholders, including representatives from maintenance, operations, research and development, and planning from our major facilities, reviewed these processes. Recommendations from the team and benchmarking activities were used to develop a leaner radiological work process. The net result for radiological workers is that 2014 RWPs will be leaner. These RWPs will continue to give clear, concise direction addressing the radiological hazards workers will encounter. Much of the information being removed from the RWPs is covered in the Rad Worker Good Practice video. The video demonstrates areas of commonly used practices that will no longer be in the RWP. It is expected that RAD workers will be conscientious and use these practices when performing radiological work. The expectation of the Radiological Control Organization is that we continually strive to improve our processes and ensure the radiological safety of all INL workers. Please take a moment and review the video. You have seen and used many of these practices. We encourage all radiological workers to use these best practices while performing radiological work. Thank you.
In this video, radiological worker good practices have been divided into categories. These categories are contamination control techniques, exposure control techniques, decontamination techniques, secondary barriers, passing items into or out of radiological barriers, sealing bags, transfer sleeves or glove bag sleeves, glove box work, fume hood work, Rad Worker 101, RWP cue cards or trip tickets, and extremity dose tracking card. Contamination control techniques. Techniques commonly used to control contamination include misting the work area or equipment prior to beginning work. Misting should not be used around electrical equipment or for flighty isotopes. Consult with radiological control personnel before using this technique. Other techniques include changing your gloves frequently during work, as directed by radiological control personnel or as discussed in the briefing. Bagging contaminated items and waste. Changing out bags and waste cans at 3/4 full rather than waiting until they are full or overflowing. Wet mopping floor areas. Wiping down equipment or work area. Taping sharp edges of items before bagging to prevent cutting the bag. Sweeping is not allowed in radiological buffer areas or contamination areas, as this may cause airborne radioactivity. Exposure control techniques. Techniques to control exposure are taught in the initial radiological worker training. They include time, distance, shielding, and source reduction. Use low exposure waiting areas while waiting during radiological work. This will increase your distance and reduce your time near radiation sources. Increase the distance between yourself and the source material using tongs or long-handled tools to reduce your extremity and whole body exposure. Decontamination techniques. When decontaminating an area or equipment, begin on areas with lower levels of contamination and work toward the areas of higher contamination. Use the wipe and fold technique, concentrating on contamination removal rather than just smearing it around. You may also consider the use of commercially available decontamination solutions, such as Radiac Wash. If the contamination is trapped in grease or oil, a solvent-based cleaner such as Extreme Simple Green Aircraft and Precision Cleaner is helpful to dissolve and break down the grease or oil. Ensure you obtain facility management and industrial hygiene approval to use any decontamination agent or solution. Secondary barriers. Examples of secondary barriers used in conjunction with personal protective equipment would include the use of adhesive knee pads, taping over the pressure points such as knees and elbows with duct tape, taping plastic shoe covers over at the knees, taping over the shoulder area to rest long-reach tools on the shoulder. These barriers need to be moisture impervious to prevent wicking of contamination. Other examples of secondary barriers would include using poly sheeting, blotter paper, or tacky cloth to cover equipment or the floor of the work area. Passing items into or out of radiological barriers. To pass items into a radiological buffer area or contamination area, hand the item across the barrier without the sender or receiver allowing their hands to break the vertical plane of the barrier. To pass items out of the radiological barriers, the receiver receives the item into a gloved hand or into a plastic bag. The sender should not break the vertical plane of the barrier with either the item being passed out or with their hands. To pass out an ED without HPT or RCT assistance, without breaking the barrier plane with your hand, squeeze the ED out of the bag and onto the ED tray at the barrier, if present, or onto the step-off pad if no tray is present. The ED must be surveyed prior to removal from the radiological buffer area. Sealing bags, transfer sleeves, or glove bag sleeves. A J-seal is performed by twisting the opened end of the bag or sleeve into a tight twist, taping around the twist, then folding the end of the bag or sleeve, forming a J, and then taping the end, sealing that end closed. Do not squish the air out of the bag, as this may release contamination. A twist and tape seal is performed by twisting the sleeve into a tight twist, tightening a cable tie on each side of the twisted sleeve to be cut, then taping around the twisted sleeve and cable ties. Next, prepare duct tape crosses to cover the ends of the sleeve, then cut through the twisted sleeve and duct tape, and apply these taped crosses over the cut ends. The last step is to tape around the ends of the taped crosses and have an HPT or RCT survey the cutter and sleeving ends for contamination. Glove box work. In preparing to work in a radiological glove box, look for sharp objects and pinch points. Ensure that unnecessary materials and equipment is out of the way. Ensure flammable materials are not present. Ensure that all required material, equipment, and tools are staged for the work. Fume hood work. Ensure the waste can is positioned in a close proximity to the hood face. Ensure that unnecessary material and equipment is out of the way. Ensure flammable materials are not present. Ensure that all required materials, equipment, and tools are staged for the work. Rad Worker 101. Remember to keep your exposure to radiation as low as reasonably achievable, or ALARA. Wear your dosimetry on the front of your body, between your neck and waist, and facing out. If an ED is worn, ensure it is in close proximity but not covering your personal dosimeter. Obey all posted, written, and verbal radiological control instructions, including instructions during briefings and written on RWPs. RWP cue card or trip ticket. The RWP cue card or trip ticket is optional for low-hazard RWPs and may be completed and used at the discretion of the worker. RWP cue cards are required for moderate and high-hazard RWPs. A RWP cue card must be completed the first time a worker signs in on a moderate or high-hazard RWP and upon each revision of the RWP. Extremity Dose Tracking Card. Use Form 441.A62, Extremity Dose Tracking Card, anytime you are required to wear extremity dosimetry. By streamlining radiological work permits, the RWPs will be shorter and more concise, with less information for radiological workers to remember. Look for situations where these good practices may be used while performing radiological work.